Dr. Guy Burroughes. I am a senior control systems engineer at Race, and I'll describe what Race is in a little bit more. So yeah, feel free to call me Guy, answer questions as we go along, and I might be able to answer them as we go along, or I'll answer them at the end. And my talk today is about Spot, the dog from Boston Dynamics, and how we plan to use it in nuclear decommissioning and beyond. Okay, so let's jump in. So I am a part of the UK Atomic Energy Authority, and the UK Atomic Energy Authority's mission is to deliver sustainable fusion energy and maximize scientific and economic impact. I'm not going to go much into what fusion energy is today. Hopefully you've been able to come to one of these previous webinars or come to an open day and been told by someone much more capable about what fusion energy is. But our primary goal is to deliver the sort of next generation of power to the world and the UK. And within doing so, maximize that scientific impact in the same way as sort of NASA has done, get all their science out of the space missions and get it into the UK economy and beyond. So as part of that, Race is the robotics wing of that aim. And we focus on any of the elements that require robotics to be able to complete a fusion maintenance task, essentially. So what we can see here is Mascot, our telemanipulator, completing a task within the fusion reactor. And so we have over 40,000 hours worth of experience of doing anything that you can imagine that requires maintenance within a complex device like this. So cutting, welding, cleaning, hoovering, wiping, brushing, grinding, what is mostly done by this robot that you're seeing here. And this is an incredibly complicated task. There's sort of 5 operators driving the robot, and there's about a team of 20 constantly online, ready to do maintenance on this robot. And this enables us to do the very complicated scientific updates to the machine, while also keeping the human operators safe from the actual nuclear experiments themselves. Back in 2015, the UK government wisely decided that rather than just keeping us very focused on this one task, we should branch out into Race. And that's focusing more on challenging environments in general. And so when I say challenging environments, I'm talking obviously fusion, nuclear decommissioning, space, mining, oil and gas. And from the time when I first started 5.5 years ago, I think there was about 30 of us. There was at least 5 in the sort of control systems department. We're now up to sort of the more 250 range, with a wide range of software engineers, control system engineers, mechanical, electrical, sort of the whole sweep of things, be able to deliver these robots. And so one of the cases that we are focusing on as a priority is nuclear decommissioning. So nuclear is a very important part of the UK's energy portfolio, adding a stable, reliable backbone for that future of energy that will have a broader range of sources coming into it. Now, 20% of the UK's energy comes from nuclear currently, and by 2025, half of that will be set to be decommissioned. So half of the nuclear reactors that are currently being used will be set to be decommissioned by 2025. Now, this is done because of general engineering life cycles. If you're going to be running a plant for 30 years, 60 years, you're going to get degradation. And at some point, you're going to want to stop operations in there and then be able to either replace that facility or take that facility down. And so that's essentially what decommissioning is. And because this is a nuclear environment, it's not the most hospitable place to humans. Now, obviously, over time, it does get better. But ideally, what you would do is send in robots to do most of the work. So pictures we have here on the left, I believe this robot's nicknamed the Elephant. And you can see it's got one of everything on it. I think this part over here is for like a jackhammer for taking out bricks. We've got different grabbing tools over here. I think this bit flosses teeth. It's got cameras, it's got wheels, it's got legs in case it gets stuck, and it's able to do numerous different tasks. On the other side, we've got the Mallard from University of Manchester. We've got Barry Lennox here today, I think, who may be able to answer questions about this later. But this is used for entering into water pools where waste is stored to be able to sample different tools. So again, saving humans going into these environments. And what we want to see within the sort of next 10 years or so is robots being the business as usual situation for nuclear sites. Realistically, as we go forwards, humans will be working in conjunction with robots to do a lot of these tasks, and this will make it a lot safer, cheaper, and hopefully faster to do the tasks that we need to do. So how does race fit into this? So in 2018, UKEA fortunately won National Nuclear Users Facility for hot robotics, and this is an EPSERT project to sort of streamline the process of getting robotics into these challenging environments, in these nuclear environments. So what does this really mean? We are planning to be able to streamline the entry of sensors from SMEs and robots from SMEs into these nuclear environments. And this goes from being able to house them in through the rest of the equipment. So if you need a robot to deploy your sensor, we can rent those for you. If you need to be able to have expertise on how you would deploy these things, we can support you. And also, if you needed to be able to do mock-ups to demonstrate to nuclear facilities, we can support you through that. And so partnering with the University of Bristol, University of Manchester, and the National Nuclear Laboratories, we aim to be able to deliver that end-to-end support and consultation on how to get robots into the nuclear facilities. And this really fits in line with the race sort of goals of accelerating that uptake of robotics in UK industry. So let's push forward onto the bit the talk's actually about. There we go, Spot. So Spot is one of the robots that we have within the NNUF facility. Well, we actually have two Spots. So it's two of the robots we have in the NNUF facility. And I've called it a highly mobile robot. So why do I call it a highly mobile robot? So commonly within robotics, there is the term mobile robot, and that generally refers to ground vehicles, tracked vehicles, something with wheels on it. And while those are excellent at getting over some terrain, what we find with Spot is that it's far more capable of being able to get over the sort of terrains that humans generally think as being difficult terrains. You know, it can get over rubble, it can go upstairs, and loose cabling can often be an issue for something like a tracked vehicle would easily get caught in loose cabling. Spot would barely even notice. So let's have a look a bit more detail of some of what Spot can do. So this is Spot the dog. He's around about 1 meter in length and about 47 centimeters wide. I'm not overly sure on that one. But think about a greyhound in size. Now, how does it see the world? So we have 5 cameras. We have 2 at the front and 1 on each side and 1 in the rear. And this allows Spot to sense the world. So these individual cameras are actually a set of about 4 different sensors that you can see here, some giving it stereo vision, some giving it color vision, all being able to be put together to build up a map of the world that then it can use to navigate and, more importantly, work out where to put its feet. So how do we actually move its feet? It's essentially a very simple system from a mechanical electromotive perspective. We have a knee joint that can move up and down, not left or right, just up and down. And then we have this rotary joint that allows the shoulder to rotate, and it can also go up and down as well. So with just those simple motions, you're then able to do some very complicated motions overall, but it's actually fairly mechanically simple. All the clever stuff then starts happening in software. So let's jump to a video, as it's been quite a long time while I've been talking and I haven't shown you one yet. So this was from about 2 years ago now. Spot first came to UKEA to demonstrate some of its capabilities. We had trialed it on some stairs. And impressively, one thing to note is that if it falls down the stairs, it is perfectly capable of taking the brunt of the force and self-righting. One of the questions that came up this morning was, does it require the arm for balance while going up the stairs? And the answer is no, it actually just capable of doing that with its own legs. And I can discuss a bit more about what it's doing there. Now, we also had the opportunity to take it into our IVTF, the in-vessel test facility, to allow it to do some play, some serious testing with our robot and get them to interact with each other. I quite wanted to see if we could get them to play fetch with each other, but it was probably out of the range for the day. So what we're seeing here is mascot on the end, the two arms. This is being controlled by an operator back in our control room, about 100 meters to the left of what we're seeing here. And Spot is then able to interact with it. All right, let's push forwards. So the first thing we did when we got it was trial it in the NIST test lanes. So NIST, the National Institute for Standards and Testing in America, have a set of test lanes that they use for flexibly testing robot systems. Now, we host the only place in the EU that has this capability, and this allows us to reliably test both the operators and the robots to see how reliable they would be in the field. So the idea would be that you would come along with your fire clearing robot, and you'd be able to deploy it in one of these test lanes 50 times and demonstrate that it works 50 out of 50. One of the test lanes that we deployed on, I'll just mention here, is lane 6, which has actually been retired from NIST because it was found too demoralizing for the operators who were incapable of both driving the robots and the robots themselves failing. And that was true for even some fairly robust looking tanked vehicles. So let's have a look at this video and we can talk this over. So standard way that you operate Spot, first of all, you have it started on its back. I'll start the video. You put in the battery and then you tell it to turn over and stand up. And it's as simple as a one button press. It has both a Python API, a C++ API, a gRPC API essentially, or just an Android tablet. So it's an app, you interact with it. You click stand and it will stand up. You grab the joysticks and tell it to turn and it will go from side to side actually. Or you can start turning. So this is the first test lane. And essentially it's a simple rumble road. It's a simple reconfigurable strip of ups and downs. If you couldn't go over this, would be quite disappointed at this point. But what we're seeing here is it can easily get over, doesn't mind drops. And interestingly, it's also got collision avoidance. So it's a settable variable that you can dial in, and it's then able to stay exactly the distance you want away from objects. It's got different gates. So the first gate you saw was a walking gate. It's also got this crawl gate where it keeps 3 feet on the floor at all times. And this is useful for when you're going over very complicated terrain like this one. Now I am going to apologize for my camera work here. I was going for sort of a avant-garde Dutch style of cinema, but might not be the best for demonstrating robots. So what we're seeing here is Spot being telemanipulated, driven from an Android tablet essentially, and driven over a very complicated field. It's using those sensors and building up a 3D map of the world, and then using that 3D map to accurately place its feet into the location that's going to be required. Now, if you'll notice, if it misses its foot location, what Spot can do, which is very impressive, is rapidly move its foot into a new location to try and stabilize itself. It is constantly trying to keep its center of mass under its feet so that it won't fall over. And what you can do is go from side to side, back and forth, moving that center of mass around. And that then allows you to drive around. So from a point of view of our first interaction with it, Spot was very much as good, if not better, than the advertising material. You know, very commonly when you deal with robots on the system, you'll find that they're good, but they're not quite as good as the best video that they found on the day. This is not true for Spot. It's very much a very complete and capable robot. And I have to actually put my hands up and say, I have to eat my own words. I didn't think there was a place for legged robots 5 years ago, I would have said, just because wheels are so much more capable and the technology looks so complex in comparison. However, this is an exceptionally good robot. Now, pushing forwards, what do we want to do then is obviously drive it remote. So this was our first test of me sitting, I'm not wearing the same shirt, fortunately, but sitting in the same place back at home, driving the robot 12 miles away back in race in one of our pit lanes to test its remote performance. So we're using this over the API. It's worth noting, though, that Boston Dynamics is working on a much easier interface for using it remotely as well. And that was very successful. So it's a very easy dog to drive, as weird as that is to say. You can choose the speed that it's maximum allowed to go to. You can choose the height at which it walks. You can choose the gait in which it walks. And you can choose the collision avoidance, so how close is it allowed to get to obstacles. And you can also dial that down to sort of centimeter levels so that when you go around corners, it'll actually step its feet around corners, staying within centimeters of the obstacle. Now, beyond this, it's got a 14 kilogram payload, and we'll look at what we do with that payload. What can we put on its back later? It's self-righting, which is excellent. It has auto walk capabilities. So if you demonstrate a walk to it, it can do it again. It's got different gaits, and many of those are quite good for doing nice tricks, remote operations, and also coming soon, self-charging. So that would allow Spot to take itself back to a deployment station essentially and plug itself in to charge overnight, ready to start operations again in the morning. Just while we're on this, this is basically what the interface looks like. And this is generally how you would actually control Spot. Now, you can control it through other interfaces. Like I said, it's got gRPC, it's got a ROS interface now. It's very easy to interface with. So what's next for Spot? So a dog's all good and well, but it would be important to put things on it for it to do. So as you saw in some of those videos, it's got an arm it can deploy, or it can deploy cameras. And these cameras give it the ability to then actually develop intricate maps of the world. So there's ones that Boston Dynamics provide as a baseline, but also many other companies are starting to develop ones of their own. So Farofocus is a company that focuses in metrology for scanning buildings essentially and taking very, very detailed models of them. It is very plausible and very easy actually to deploy one of these on the back of Spot, have it go to a distant location or repeatably go to a location, and you'd be able to take a scan. One of the ways we envisage seeing doing this is with something like the Createc Envisage. So, oh, I've lost the logo. So there's meant to be a Createc logo, but Createc is a local SME focused around one of their areas is mapping out radiation environments. So what you can see here is a point cloud generated from essentially a laser beam and a camera, taking a 3D model of the environment, measuring out all the distances, so you can actually recreate what you have in the 3D world. And then, more interestingly, overlaying the radiation map that you're seeing there. So the orange, brighter areas are areas of high activity of radiation. Now, while these are probably actually quite low, ideally, what you would be doing is minimizing your operators going to these areas or triaging what you're doing in these areas. So if you could tidy up these areas first and in nuclear decommissioning, that's what you could do. Or if you could use something like Spot the Dog and a robot vacuum cleaner, that's another option. But the ability to go in without a human going in first and sensing these areas, making sure a human can know where it's dangerous for them to go, is very powerful. However, before we can send Spot in, we need to start thinking about contamination control. So obviously, Spot, radiation and Spot do not mix. And we also do not want to have the operators who have to maintain Spot to be able to come into contact with contamination either. Simplest way to do this is cover Spot in a very stylish rubber coat. So the waste management group at Race and the plastics workshop has kindly put a lot of effort into developing a unique coat setup that has air filters and air vents to allow the motors and the batteries to be cooled, but also to give Spot the full range of motion without being limited. And this was actually surprisingly challenging, as you can imagine, with a robot that has quite a range of motion as Spot does, but also staying covered in all locations. So we had one design like this that covers the legs. We have another that covers the full body and the legs, and those two combine. And we have different methods for stopping ingest into the motors or to the computer via the fans of any sort of dust that we didn't want to go in there. And so this allows us then to go into challenging environments. So one of the really exciting, challenging environments that we were able to test within was Chernobyl. So if we push forwards, University of Bristol, Professor Tom Stott and Dr. David Megson Smith had the opportunity to take some of their robots to Chernobyl, and we had the opportunity to support them in supplying a Spot. So as not all of you may be aware, Chernobyl was a nuclear facility in Ukraine, where there was an incident involving the blowout of nuclear material into the local environment. And this has meant that for the last 30, 40 years, human inhabitation has been impossible, and there has had to be quite a large amount of decommissioning effort towards this, including taking off top layers of soil in the entire area, and more importantly, what you're seeing here. So directly following the incident, essentially the first response was to get some very large concrete Lego bricks and pile them up over the top of the building to make sure that nothing else would happen. And so that was what was described as the sarcophagus. It was completed very quickly and was very capable in what it's doing. However, in 1995, it was deemed that the sarcophagus needed to be deconstructed, maintained, and made sure that nothing was going to get out of it anymore. So this extra facility was built over the top of it. So this is an incredibly large facility. It was lowered into location in 2016 or thereabouts. And essentially, it's one of the world's largest buildings that was then used to be moved on rails onto location. So it was built just off to the left and then wheeled into location. This has now meant that you've got a very large area that has nuclear contaminants in it that we wouldn't want humans going in on a regular basis. That requires measurement, scanning, recce's. And one of the options for this is Spot. So we've got a video that was released onto YouTube via Chernobyl a couple of weeks ago that I can re-show, demonstrating our brave little Spot going off into Chernobyl. So what we can see, this is Dr. David Megson Smith. My Ukrainian is not very good, so I can't translate that, sorry. But essentially, they have a CC Reyes camera on the back that's able to sense radiation in the environment and overlay that onto camera feeds. And it's on a 3D gimbal, so it can turn and look. You can see there, because of Spot's uniquely small footprint compared to most other robots, simple Veruca socks or plastic wrap is capable of protecting it from the environment. And then in this first entrance, Spot is able to, with support of quite a few people in protective clothing, go off and investigate the area. So that is the sarcophagus. And Spot is then able to walk off by itself and inspect. Now, as we were going forwards, the idea would be to not have quite so many people with it, obviously. It would be to use the auto walk feature that I was talking about earlier. So allow Spot to be trained to do a certain route and then be able to carry out that route again. And it's worth noting that auto work capability would allow it to dodge items in the field and return to the path it's trying to do while still being flexible enough to actually deal with the real world. There we go. And I'm sure Tom Scott in the future and the team from University of Bristol will be releasing some very exciting footage of what the radiation scans look like and what the radiation paths look like into the world. And this will be able to support the team at Chernobyl in, first of all, identifying areas where they want to limit human access, but also act as a triage for taking apart this facility. What areas need to be cleaned up first to reduce the contamination as we go forwards? If we can take out the most dangerous parts first, or the most dirty parts first, it's going to make the whole process going forwards a lot easier. So beyond this, we are planning to deploy next week into waste storage monitoring. So when you're completed with a lot of this waste, and even low-level waste of the rubber gloves that we all saw that people wearing, we have to store that for a period of time, and we do so in barrels, like you can see here, standard ISO drums. These need to be maintained, these need to be monitored. Very simple thing for Spot to be able to do is to start auto-walking and monitoring these barrels. Other things that would be excellent is emergency response. So if we had an incident, regardless of whether it is nuclear on a site, and there was rubble in the way and we wanted to get in and see what was happening, Spot could be a first respond unit to go into that environment. Similarly, it's very common in nuclear environments and nuclear decommissioning for cells to not be fully characterized before starting. A lot of these facilities were built from designs made in the 50s and 60s, built in the 70s, worked for 30 years with 10 years worth of good maintenance going on in there and changes and modifications to make it last longer. So not all of the environments are well characterized. So sending Spot in for the first time to understand exactly what we have and assess the safety for humans in this environment is a very powerful, important tool. So I can roll back and start showing questions if we need, but let's have a look at the time. Any questions? So I can see one question straight away. What is the radiation resistance of Spot? Dose rate, integrated dose? What is the cost of Spot? Do you rent Spot? So that's a very good question. What is the radiation resistance of Spot? The same as your home PC, essentially. So Spot is in no way designed or modified to survive neutron bombardment or gamma rays. It's very much the idea that it stays out of the most dangerous locations. However, robots are inherently more capable of dealing with radiation than humans. So the way that radiation affects computers and motors is through degradation. So in a computer, things can happen like bit flips, where a single piece of radiation hits a part of the chip and changes one bit, a 1 or a 0, to the opposite way around, or it can break it entirely. This is not ideal, and it can degrade the performance of the robot. However, it's much higher that happens than it does for humans. So Spot would be able to do 90% of a nuclear decommissioning environment and look into the dangerous parts without getting too much of a damage. Now, how much does it cost? They're currently selling them for around about $75,000, which is actually surprisingly cheap compared to the rest of the market. And yes, as part of the NNUF facility, we do rent out Spots, and we rent those to SMEs and UK universities. And through the UK universities, there is actually a scheme for UKRI to support that funding for the rental as well. Right, let's have a look in the Q&A. So if you feel free to put your questions into Q&A and I'll start answering them. Or can you move the microphone out of the way of your face? Oh, a bit late. But yes, I can. I'm not overly sure. It gets a bit quiet when it's not directly in front of me though. So click answer live for that one. All right. Hello, what are the operating conditions in the machine when you use the robot? Vacuum, temperature, thanks. So when we use the mascot, which I assume you're referring to from when the question was asked, it is very much turned off. So within the fusion reactor jet, we get up to 150 million degrees Celsius or Kelvin in the center. That would melt about most things. So generally what we do, what we do is that there is a shutdown period or a period when we want to do maintenance. The machine is turned off for a period of time to allow it to clear out and vent. We then take off some of the robot equipment on the outside or some of the diagnostics equipment and then use that to entry through one of the port doors. This is actually quite a slow process to get in there. And that means that the robot doesn't have to really worry about temperature, but it does have to worry about contaminations from things like beryllium and also neutrons somewhat and gamma somewhat. So Mascot itself is actually very tolerant to nuclear environments and some of the complexity in how it's designed related to that. So yes, most of the areas, so this one's from Matthew Carr, most of the videos have shown Spot on flat floors, etc. Have you managed to take Spot into any challenging real areas, debris fields, rubble, collapsed buildings? So I don't have any access to collapsed building myself, but we have done stairs and rubble and sort of just normal operating style in a decommissioning environment. So in a decommissioning cell or a nuclear cell, it's very common for operators to have gone in. They fully PP up. They wear 2 layers of rubber suits and air vents, and they take in a toolbox with them. And because that toolbox has then become contaminated, what they often do is just leave it in there on the floor, sort of just throw it to one side. This means that Spot does need to be able to capable of get over just loose debris. And in testing, it's been very successful in that. What does Spot do when it loses remote connection? It sits down. So there is a constant back and forth between you and Spot. And within, I think it's within 50 milliseconds, but you can dial it in essentially. If it loses that connection, it will sit down and then wait for you to reconnect. There is experimentation to go forwards on whether we would want that to do that. Maybe we would want it to slowly return itself back to the safest location that it knew where there was connection. But for the moment, the safest thing for it to do is to very slowly and carefully sit down and wait for help. Were you able to assess the effectiveness of the plastic suit in protecting Spot against contamination? We are actively doing that at the moment. So on the way out of Chernobyl, Spot was assessed both by the University of Bristol and by Chernobyl's health physicists, and they cleared it for movement. So obviously it worked in that respect. And we're also doing our own tests at the moment. What limitations did you observe in Spot currently, and are you aware of plans to improve them? So limitations at the moment are more into remote operations. So they're developing their capabilities for supporting a fleet of Spots going off into the world. There are issues on auto walks for crawls. So obviously the crawl gate is more useful over difficult terrain, and I don't believe you can auto walk in a crawl yet, but someone might say I'm wrong. And I'm still very excited about the arm. So they haven't released the arm yet, so I'd be very interested in seeing that. Alex Meekins says, how well does Spot cope with damage? Change to internal model of self. So as I've mentioned, I've seen it fall down a very heavy flight of stairs from a great height and at quite a good speed, and it dealt with it quite well. So it's very robust. I've also messed around with what it thought its payload weight was, and it dealt quite well. So when you chuck a heavy weight onto its back or tell it that there's heavy weight and there's not one, what it will do is it will keep trying to move its center of balance to keep on top of it, but it is still able to walk. We have discussed directly to their engineers on how we would deal with the loss of a leg. Can it drag it home? One of them said that they've seen it do it in the lab when they've accidentally broken it, of being able to kind of balance itself on 3 legs, but it isn't designed to at the moment. Anonymous attendee, how do you ship Spot around the world, UK? It's challenged due to its size, value, large batteries it must contain. Yeah, it's an interesting one. So it comes in a big Peli case, essentially. It's a big foam box, and the box weighs about an extra 150% of what Spot weighs for the amount of foam. So it ships very nicely on a plane, and that's how we've got it from America and then back out to Chernobyl and back to us. And we ship the batteries first. So they're lithium ion batteries. So they're not lithium polymer, which is the most dangerous type at the moment. They're sort of standard toy car batteries, but we do ship those early just in case there is an issue, but they are quite standard COTS devices. Do you see any use of Spot in active nuclear plants, fission and fusion, as well as decommissioning? Definitely. So from a fusion device, if we're thinking of a plant like Demo or ITER, which is a sort of next generation demonstration plants for fusion, the facilities that surround them, including the robotic facilities, the areas that maintain the robots that do the robotic maintenance, and there's a sort of robotception there. We're expecting robots like Spot to be doing sort of patrols of that area, looking at the concrete, checking it's okay, looking for things that you know, a normal human being engineer would do as they walk around and kick the tires of their new building. And this goes with fission as well. We see a very active opportunity for this. Do you think that there will be a place for bipedal robots sometimes in the future to do this kind of work? As I mentioned earlier, if you'd said that 5 years ago, I'd have probably vaguely laughed and said no. But now, yeah, definitely. Especially the hybrid ones. So Boston Dynamics has a legged wheeled one. So it's got 2 legs and wheels on the end. It kind of segues around, if that's not the registered company name of a different company. But that then gives it a capability of both. I think the ability to interact with the world in the same way as humans do, so that we don't have to change the world for robots, is going to be necessary for a lot of these items to be able to get into the home. So in the case of a single event effect, would it be possible to remotely reset and restart Spot? Yes, so actually auto cycles itself in as I've seen for when you can cause faults. There's nothing stopping you being able to interact with a lower operating system, or even we can add a RAD hard computer to the side that would be very tolerant but very simple to be able to do that cycling. So single event effects, just for everyone else in the chat, would be a nuclear particle or a radiation impacting a part of the computer and causing, as I was mentioning, one of these bit flips or something within the device to have changed because of that energy release. And often a way that you can fix this is just by turning it off and on again as the power resets itself. So yes. So how long does it take for Spot to detect obstacles and respond accordingly? So its internal vision cycle is very fast. I'm not actually sure the rate it's running at. However, I've run it at full speed and sort of pushed stuff in front of it, and it was able to dodge it instantly. So within the loop cycle of the control pattern, I would say. I do have a video, but I won't drop it out now. The voxelization map that it uses for moving around is much simplified to what you would imagine. So it reduces everything down into sort of the area where a foot could stand. So the voxels aren't much smaller than that. Now, obviously, there's going to be details that it then throws onto that to say, here's a fence, here's a thing. But the level of detail out of it is not very detailed. So this is why you then need to put mapping equipment on its back, because it's not looking to do mapping. It's looking to do navigation and step prediction. I guess the auto walk is a teach and repeat method. Have you tried running it yet? What is the limitation of the auto walk performance? Yes, it is very much a teach and repeat. There are people like Maurice Fallon at Oxford Robotics Institute who have their own methods that we're going to be trialing soon for non-teach and repeat, so actually using full SLAM to go off and do mapping and localization. But having run it in real world, it runs how you kind of imagine it would do. It can become a bit lost. If you add a whole new obstacle, it will struggle. If you put a mesh fence up in the corridor, it will keep bouncing off the obstacle until it gives up. I think on its third attempt. It does require fiducial markers or AR markers, QR codes to be put in the world to have start positions. And the other half is a limitation to that one. It doesn't tell you where it is within that path. So it doesn't actually relate to a physical map at the moment. It's just to its navigation map. So it is just repeating what it's been shown, and it's only remembered exactly what it's need to do that, not more that would be useful for a human operator, let's say. What does gRPC stand for? Oh, I think it's Google's remote procedure call. So essentially, it's a API method that allows you to do remote procedure calls, as in ask the robot to do something or ask the robot to respond and tell you something via a sort of standard internet protocol that different programming languages can interact with. I'm sorry if it's not Google RPC. I know they had involvement in it. In relation to control of Spot, are there any plans to set up something more sophisticated, similar to Mascot, with a designated screen and perhaps a joystick? I'm not overly in relation to control of Spot. Are there any plans to set up something more sophisticated, similar to Mascot, with a designated screen and perhaps a joystick? Oh, I see. So like a master device for Spot. Yeah, I think so. There's nothing stopping us. But one of the benefits of Spot is that at the moment is how easy and simple it is to use. So Mascot, the operators require sort of 200 hours of active operations training before they're allowed to do anything serious. And the good ones have 1,000 hours. It's also worth noting they can tell within the first 5 minutes of training whether you're going to have the sort of geometric capability to work out what they're doing, because it's very much a difficult 3D rendering problem in your mind. So if you're imagining you've got your master station, you've got your robot, your hand, you're holding it like this. Let's jump back to a video. Things that are going to be an issue, you're looking at 2D screens. You don't have any depth visions anymore, so you can't tell how far away that is unless you look at the other camera. When you look at the other camera, it may be inverted because the camera is upside down. You can see here, Tim, who's very capable, was skidding off and missing the screw because it's very hard to feel what you're doing. The simpler, the better we can in this environment. We want to be as easy to use for lots of people. What is the battery backup of the bot? Is it capable of working inside the tokamak? Battery backup of the bot. So it can run for about 4 hours, and it can go for longer if you give it time to sit down. It takes about 20 minutes to charge a battery, and you can hot swap the batteries. Is this capable of working inside the tokamak? There's nothing stopping it. However, I think, I don't know if you can see my mouse, each one of these tiles is probably worth about 50 grand. So we really wouldn't want something scratching them up with their rubbery feet. Hence why Mascot has to be very careful about not touching things. But there's nothing actually particularly stopping it. As you saw, we have taken it in the in-vessel test facility. How does AI help? Okay, so artificial intelligence on board Spot. How do I stop the annotation, or can't I? No, I'm just annotating for life now. So on board, it has a CPU, GPU, and it has specialist hardware for doing neural networks. And this then enables it to estimate rapidly where its feet are going to go and how to keep the different motions in line. So this is all the artificial intelligence. Keeping it standing up is a very, very complicated task, and they're doing it through software primarily, and that is AI. How can Spot be more useful in industrial areas? It's the tooling. So there are many companies out there at the moment focusing in different areas. There's some deploying Spot into North Sea oil in Norway. There's companies for construction sites. So one of the places this can be very useful is for builders, or at least architects, to be able to have Spot deploy on a daily basis and take a scan of the environment and see how it's progressing. And this helps make sure that they're keeping a line with what they're meant to be building. So I would say it's primarily the actual deployment into the environment. I think also having the self-charging stations will help to minimize the actual hassle it is for operators on a day-to-day basis. Is it water resistant? Resistant's the right word. So there's companies like Animal that also produce dogs, a European company from Switzerland, I think, that is waterproof. It can sit in puddles, and they've tested it up to certain IP ratings. Spot can deal with light dampness. It has got large holes in it for air vents, but there are ways of dealing with that if you wanted, like a big rubber coat. To change Spot's behavior, are you able to modify the core internal software or limited to features provided by the vendor? They do intend it to be locked down, and they do intend it to be very much a black box. It's a navigation device that you stick your payloads onto. However, their API, which is available on GitHub, is it does give you the capabilities of adjusting it to some degree. You aren't going to be changing the foot location or where it's putting its feet at any one time. Frankly, you probably don't want to, because it's as good as it needs to be. If you were in the research field and wanted to get, you wanted to get into the ROS side of things and tell exactly where you're putting the foot, there are other companies like Animal that would be perfect for that type of thing. They're also kind of more open about the modifying the robot itself as well. Yeah, what access do you have to Spot's low-level systems? Could you, example, alter the control systems used on one of its legs? No, you couldn't affect one of the legs. You can tune parameters. You can ask it to do certain gates. You can drive it. You can get access to all the sensors and motor temperatures, and you can control it to walk in certain directions, but it is designed to be quite locked down. So while they do intend it to be just driven as if it was a car, you're not going on the inside of the control system and affecting it. You're not affecting where the foot placement is. However, they are very responsive to people requesting changes, and they are interested in expanding this in the future. So if there was particular requirements, they would actually be very responsive to making those changes for people. Boston Dynamics is also working on Atlas. If I'm not wrong, you're not wrong. How is Spot going to be competing against it? I mean, is Atlas just going to be an update of Spot? Spot would still be such a mobile platform compared to Atlas. I think they're very much for different applications. So Spot, Atlas is coming along soon. Spot is sort of probably 5 years down the line in development terms from where they were. With Atlas still has a lot of sort of battery concerns and payload concerns, I assume. But they would be focusing on different environments. So the benefits of an Atlas would give you 2 arms, 2 legs to be able to interact with the world as a human does. However, if you just need to deliver some cameras to some locations or take 1 arm to do some simple telemanipulation tasks, Spot, being so small, agile, is probably going to still be your answer. All right, how supportive is Spot to be to the customized device, such as protocol or channel for own developed devices, robot arms, grippers? Yeah, it's surprisingly good. So essentially what you're getting on the back of Spot, and I wish I could work out how to change the slide. Oh, I can. There we go. So just on the back of Spot, we have 2 interfaces, and we also have an RJ45 connector at the back. In this connector, they output 3 different types of power: 5 volts, 12 volts, and 24 volts in unregulated power that you can regulate yourself. And you also have access to their data. So whatever networking system they're using, whether they're using Wi-Fi, which is their primary internet connection, their wireless connection, or if they're using radio frequencies, you can hook into the back of that by accessing their IP network, essentially. They have just released a new patch of their software that actually streamlines that as well. So if you were getting data from one of your payloads, they have a platform where you can upload it to give it a more streamed download as well, rather than just taking up all of their networking. What are the developments have you made in completely automated operations in the future, say doing routines inspection by itself without any human interventions? What developments have we made so far? Not many. It's been more primarily focused on the type of developments we'd need to do to get it in its current form. However, in the future, research facilities like ORI are looking heavily into how we could do these automated operations, and we'd look to partner with them, or at least utilize their research, or the research coming from groups like RAIN, RAIN being a EPSRC hub focusing on robots in nuclear, in best ways to deploy this. I was wondering how the use of robots for Fukushima has been influenced your use of robots. A bit of back and forth, I think. It's great seeing that Fukushima is excited in using the robots, as they should be, and they are the right tool for this job. And Japan is, as they were hoping to demonstrate in the 2020 Olympics, all about robots. They're full steam ahead with robots, and this is one of the places where they demonstrate this with. I think we have conversations with Fukushima around robots, and I think these are the type of robots that will be coming up in the future of how they deal with the system. It's worth noting that Tom Scott, University of Bristol, who deployed this robot to Fukushima, to Chernobyl, has actually done drone tests at Fukushima using the similar sort of sensors to be able to assess the situation of sort of material stores. So there is high overlap there. How do you plan on bringing Spot to the corporate field so that more and more industries might have advantage of the mobility of Spot, considering the price at the moment is still high for many small industries to afford? Yeah, it's a good question. So as part of NNUF, we are renting it at a reasonable price for companies to be able to assess. You know, it's a big single off purchase if you're not sure you're going to want it, and you're not sure if it's actually going to be useful. It's hard to know until you get your hands on these sorts of pieces of equipment. Is it going to work for me? So that's how we're sort of initially doing that, and also offering the consultation on top of that for how you might deploy in a nuclear environment. And that, again, is not an easy point. Okay, has Spot ever met a real dog? And if so, what did the dog make of it? There are videos online. I haven't done it. I know my dog seems to act annoyed whenever I'm talking about it. It was sitting next to me a second ago, and it sort of stormed off when I started talking about Spot. So I have to say, for my own personal sake, when you get it sort of, let's go on to some videos rather than a still image. When you get it sort of wagging its tail and sort of looking around at you, it's quite unnerving how realistic it is, and you kind of forget what you're looking at for a second. Yeah, it moves very fluidly. Hello, what type of new sensors do you plan to test on Spot? Nice presentation, by the way. Thank you. So we're looking at a whole range of things. I don't think there's any particular one. Farofocus scanners for meteorological scanning is obviously a great place to go. CC Reyes or Createc Envisage, you know, something that can detect gamma radiation. Other cameras that perhaps can do beryllium detection would be exciting. Essentially anything that we would want to be able to scan inside of a nuclear environment we would ideally want to be putting on the back of Spot. With its 14 kilogram payload, it can take quite a lot. And I know that Spot has been pushed up to 40 kilograms when it's being used by the NASA DARPA X Challenge for going underground terrain exploration. And I know they had to do some changes for that, but it doesn't stop us from requesting those same changes to be made as well. And that would enable us to take some very heavy payloads. Beyond that, I think we'd want to also do some sample collecting as well. So with something like the arm or another device that could be mounted on top, there's nothing stopping you being able to go to a location, take a swab of a sample, pick up something off the floor, put it in a rubber bag, and then take it home so that you can check it out. And that's another place we can do. Can Spot cope with slippy falls? Yes, and there's videos online of it going on ice. We've also had it on sort of paper that's flipped away from it as it was walked over, and it just found a new footing place. We also found with the sort of plastic covers on the feet, that did obviously add a bit of slip. It did make Spot look a bit drunk. But if you put it into a crawling mode where it's much more careful about where it puts its feet, it is capable of dealing with that. With the development in the camera technology, would it be feasible for in-service inspection, world inspection? Yes, definitely. I think beyond that as well, I don't think there's a reason why you couldn't mount small, highly dexterous robots onto the back. So something like a University of Nottingham snake-like arm to be able to take Spot to a location and then have it reach inside of a pipe and do world inspection from the inside and out as well. Do you have to wash Spot after a trip to Chernobyl for decontamination? So elements do come off of it that we could have washed. I think more likely it would have been a very slow and careful swabbing job. We try not to contaminate water as a rule. So if you're washing it, you're then getting contaminated robot and water, which is not great. And also electrical bits and water is never quite a good idea. So it's generally sort of alcohol wipes and wiping it down. Being the Nerf gun all weigh less than 14 kilo. Oh yeah, it would be great to, especially if we could have like a little turret gun of a Nerf gun on the back of it, or water pistol. Great for the summer, and we can have it sort of sneak around because it's pretty quiet as well. How many attachments can we have on it? As many as you like. So what you can see there, it's got two 20mm aluminium extrusion rails on the back, and it's got two electrical power ports that you can connect to. But there's nothing stopping you sort of daisy chaining things together and stacking this thing, sort of 20 meters tall, as long as you didn't go out of that 14 kilograms range. It's worth noting though, if you are going to go super tall with the device, your center of mass is going to become an issue, and Spot is going to be constantly fighting itself to stand up. Is it possible to hack any of this dog? So plausibly, so computers are inherently hackable to some degree. However, there are things that we can do to avoid this. First and foremost is air gap. Make sure that no one can get to its networking, and then it becomes easy. Make sure no one can plug into it, and that makes it easy. Beyond that, all the sort of standard precautions over proper Wi-Fi management, proper web interface management, passwording, HTTPS, showering all of your messages coming across can be done. But it's inherent to computers to some degree that they can be hacked in the same way mechanical objects can be hacked if you can get your hands on them. The trick is just making sure people can't get their hands on them, I suppose. If Spot can be modified to carry up to 40 kilograms, is there any scope for building shielding systems to allow it to work in more radiation areas? Yeah, I do believe so. And in particular, it's probably actually very small areas that need the significant amount of shielding. If we're willing to sacrifice cameras over time and just replace them and say we just want to be able to have the computer shielded and perhaps the motors, these are definitely things that we can do. A very small amount of lead around the computer would go a long way, and maybe just swapping out the lubrication inside the motors would do a huge amount of difference as well. So that's all the ones in the Q&A at the moment. I noticed there's been a few floating around in the chat, and I just noticed one. Have you used Spot to operate any maintenance and assembly tools like those used on Mascot? So without the hand, we can't do anything at the moment. However, we have used cobots to do those sorts of things. So as part of the RAIN program, again with Barry Lennox and University of Manchester, Sheffield, Oxford, Bristol, several others, we have been working on sort of glove box technologies where we use cobots, so very flexible, human-friendly robots to be able to work in nuclear environments. So there's nothing stopping us, particularly if we wanted to go that way, attaching those sorts of robots onto this sort of platform, and that would give us a lot of capability. All right, I think that's all the questions.